In geometry, we'll be running across three different types of means throughout the year. The first is the arithmetic mean, but there's also the geometric mean and the harmonic mean. The arithmetic mean is the one that's most familiar to you. It's the average. And if, for example, we wanted to get the arithmetic mean of 2 and 18, the way we would do that, as you well know, is to take half of their sum. And half of 2 plus 18 is 10. And the arithmetic mean you can actually visualize using a sequence of numbers. If we put 2 and 18 into two places, and we want this sequence of numbers to always add by the same amount each time as we move along, the number we'd want in between is 10, because that way we add 8 each time to move from spot to spot. Okay, let's look next now at the harmonic mean. So I'm going to delete what's here. And it may take a couple of moments to do that. And let's now look at the geometric mean. And again, I want to work with 2 and 18. The geometric mean requires us to multiply the two numbers together and then take the square root. And in this case, we get 6. And a geometric sequence involves multiplication. So if we have a sequence of numbers like this, and we wanted to have 2 and 18 in those spots, and we want it to grow by multiplication, then the number we want to put here is the number that creates a multiplication that goes from 2 to there, and then the same multiplication that goes to 18. And the number we want to put here is 6. And that's because 2 times 3 is 6, and then 6 times 3 is 18. We're always multiplying by 3. And as you progress along a geometric sequence, the numbers get big very, very rapidly. All right, let's now look at the third type of mean, and that is the harmonic mean. So I'll get rid of what's here. And the harmonic mean is the messiest of all. Again, let's work with 2 and 18. The harmonic mean is the reciprocal of the average of the reciprocals. And that's a handful, but we can clean that up pretty nicely. First of all, notice that these two fractions we can add up. This is 9 over 18, this is 1 over 18, so together they are 10 over 18. And then we have to multiply by a half, and when we multiply those two together, we get 5 over 18. And then finally, we have to take the reciprocal of that, and our final result is 18 over 5. And 18 over 5 has a different sort of interpretation than the earlier means, and it actually has a musical interpretation. If we have a string of length 2 and a string of length 18, the string in between that makes a harmonic sound will be 18 over 5. And if you look inside a piano, or you look at a harp, all those different strings are lengths of various harmonic means. So we'll be seeing these three means a lot in the coming year. There's one final comment I want to make about the harmonic mean, and to do that I want to delete what I have here. So I'm going to go ahead and delete these different parts. And there's one sequence that actually is called the harmonic sequence, and it is 1 over 1, 1 over 2, 1 over 3, etc., etc. And it goes on forever. And each fraction in this sequence is the harmonic mean of the two around it. And I want to give you just one example of that. So let's look at 1/2 and 1/4. The harmonic mean of those two fractions should equal 1/3. So we'll do the harmonic mean, which is 1 over 1/2 times the reciprocal of a half, which is 2, and the reciprocal of 1/4, which is 4. And when we clean that up, we get 1 over 3, which is the harmonic mean. And that works for every fraction in this list, in this sequence. Each one is a harmonic mean of the two around them. And because of that, this sequence of numbers, of fractions, is called the harmonic sequence. And that's it.